Good morning. It is Wednesday morning, 9:30 a.m. As promised, was told you that I would give you a little video with some things to think about for our upcoming test on Friday. So the first reminder I would like to tell you is we'll all be taking it. So whether you are here or you are virtual, uh, we're all going to take it at the same time. And the notes are okay uh, if you're here or if you're virtual. Reason being is I want to be fair to all. So, with that being said, let's go through and talk about some of the things you might want to know for this. Number one, the format is still going to be multiple choice and free response, just like you'll be facing in May when you take the big exam. I have 12 multiple choice questions, and from those, I would like you to select 10 and 3 free response questions. What I decided to do today, so the video wouldn't go on a long time. We know how we like long videos with teachers. I would start by doing a video on the multiple choice questions, some just hints and things you might want to look at, and then I will stop, and then I'll collect a few notes, and then we'll have another video for the free response questions. That's how I decided I wanted to do it. So, okay, these are things to think about. They are in no particular order with the multiple choice questions, but they are certainly things you might want to think of and study on before you get to taking the exam. Okay, let's start with the first point. Absolutely vital that you know the computer output for a linear regression. So in your book on page 183, this comes up multiple times through all the questions. So from that output, you should be able to get the explanatory variable, the x variable, the slope, the y-intercept, and the r-squared. They are all labeled on that graph in page 183 of your book. All the rest of the stuff you don't need to know now, but all those things. The two variables, they are called the independent, which would be the explanatory, and the response variable, which is the dependent variable in that little graph. But other than that, it's all labeled right there. The constant being with the y-intercept, you have the explanatory variable and the slope right next to it. So any output you see, it might not look exactly like that, but those things would certainly be similar to what you see on page 183. Okay, so make sure you know that. That would be point one. Point two is the idea of we have outliers in one variable statistic. Well, there are outliers in scatter plots, two variable statistic too, but they're not the same. First off, there's no mathematical formula for them. It's just this is what you would look for, is a data point that has a large vertical distance from the regression line. So something, not just distance, but the vertical distance from the regression line. And the question you will see that there is no question this one has the most vertical distance from the regression line. And when I say vertical distance, I mean up from the x-axis straight up from that. All right, that was our second our second point. Our third point is the whole idea of using the slope formula. Now, remember, slope is B1 equals R times the standard deviation of Y over the standard deviation of X. So I guess what I would say for this one is make sure you can do your algebra. They might give you the slope and you might have to manipulate around. So you would know how to do that. I mean, that's simple algebra, but I'm just saying it is possible that with there being 4 variables right there, they might ask you for another variable, not the slope, and they give you the slope. And you definitely will see a question like that. That's point 3. Point 4 is once again, from the computer output, you are able to find the y-intercept. And the y-intercept, it's right to the right of what says intercept on the computer output. So it should be pretty easy to find. Okay, that's point 4. Point 5 is point 5, I would say, is just basically a plug-in. You're plugging in a value into X. Remember our everything revolves around that for us, where this is the predicted Y amount, this is your y-intercept, this is your slope, and this is your X value. Keep in mind the calculator and also our book, our website, rather than BO calls it A for the y-intercept, and the slope it calls just B. So it would be y hat equals A plus BX, like that. Okay? But they both have the same form. They just use different symbols. So, you can do that. We had many problems. You just plug in an amount and get a predicted value. Once again, could come up. They give you the predicted value, and you have to do the algebra and work back for one of these other variables. Keep that in mind. And that would have been 1, 2, 3, 4. That was point 5. Should have I got these numbered backwards. Point 6 is the coefficient of determination, which is R squared. Now, first off, R squared, you can, if the coefficient, the correlation coefficient R is given, you can certainly find R squared by squaring it. Other applications, remember I said as far as that sentence is concerned, it is the amount of variability in the response variable that can be explained by the variability in the explanatory variable. But remember that conversion, R to R squared, a little just basic algebra there, but that should be no problem. So that is 1, 2, 3, 4, 5. That was 6. Point 7. Now listen up on this one, because I don't think we use this term at all, and they use it in the question. Hopefully, you could figure it out anyway just by your use of context clues. But if they're talking about a high leverage point for the regression equation, that would be something that is really close to the line. High, you draw that imaginary line through the points, and a high leverage point is something that's right near the line. So of all the different choices given, there's one that's very close to the line. All right. Next, Residual plot. Remember, how do you get a residual plot? You plug in all the x values into L1, and you take the regression residuals and plug them into L2, and that gives you a plot. Well, let me give you a clue. You don't have to draw a residual plot. You only need to be able to interpret it. And what is the interpretation? The interpretation is that there is no pattern. If there is no pattern, then the linear model is appropriate. But if there is a pattern, whether it be some curve, parabola, some kind of wave, or just a linear pattern, for some pattern in that residual plot, clear pattern, then the linear model is not appropriate. Okay? Next is the idea of what, well, you look back up at the board there, y hat. What does that mean exactly? That doesn't mean it has to be that amount. It is the predicted amount. Okay, so y hat. We talked about the price of gasoline in 2008 and plugging it in with the regression line in 2008 and getting a predicted value. Well, guess what? That predicted value would have been wrong because of other variables. But in general, y hat means the predicted response variable, not necessarily the actual response variable. And going along with that same concept, the next point is the idea that you have the limits of your data, you have the minimum and the maximum of the x variable, the explanatory variable. Anything out beyond that is not relevant for prediction for the linear model. So that's what I meant on the last question when we were talking about 2008. Extrapolating, remember that's our word, out to 2020 to find the price of gas would not work. So don't do that. Okay, once again, residual plot. Residual plot is that one final check on whether the linear model is appropriate. So as far as any type of graph that you've dealt with all year, if you wanted to talk about the appropriateness of the linear model, you would be talking about the residual plot. And then final point for multiple choice. There's another video coming. Like, wow, we're up to 13 minutes now. So I've got to wrap this up. Final point is know the two variables. The x variable, which is the independent variable in science, is called the explanatory variable. The y variable, which is the dependent variable in science, is called the response variable. Know those two variables. A question might be which one is which. Usually, unless otherwise told, but in the problem, the way they're presented, the first one is explanatory and the second one is response. Plus, it makes sense that one would show would necessitate a relationship with the other, but not enough of the big words. But I would just say whatever one is presented first would be the explanatory variable. Okay, the video is under 50 minutes. I think I'm so happy that you would watch it. It's a good way to get somebody to watch your video to make sure it helps you on your exam preparation. We're hoping for another good average. Last time the average was good, and we're hoping for it again. Okay, so I'm going to post this real quick. I would look at it over and over and over. Okay, we'll see you later. Bye.